So this is like your little mini lecture on experimentation. It will be available to you on YouTube, on my website. I will upload daily lectures. And here's my thing. I really would just listen. I wouldn't feel the need to write this down. Just listen. I think most of it will make sense. And of course, you'll have access to my notes through my website. So big thing with experimentation, we always start with some problem or phenomena. For you, it will always be given. I will literally give you a handout, okay, with the task at hand. It is known as purpose, objective, or whatever. Generally speaking, when you're reading that task at hand, okay, Julian, could you put the phone down, please? When you're reading that task at hand, do not write the entire background into your lab notebook. I don't care. All I want is the purpose at the end actually translated into your lab notebook. Okay, so don't write the whole background. I don't care. I already know. It's mainly for you to understand what the purpose is, bigger idea. So you start with some task at hand, some phenomena, some event in the world, some problem, some question. And then what you do is you're going to try to create a detailed and replicable procedure that addresses that purpose, task, or question. Now, that will be given to you in every circumstance, essentially. You will never be asked to make one because we don't got time for that and you're not skilled enough for that, okay? But that being said, you'll notice that all of the procedures involve some type of independent or dependent because we tend to do experimental based investigations or procedures. There are three categories of the types of like labs you can run. We tend to do experimental because we tend to focus on cause and effect. We're not exactly asking you to find like a constant, like the gravitational constant, right? Like you're not skilled enough to do that. We don't have the equipment to do that. Cause effect is easy to do in the lab, okay? Especially with our very old equipment, okay? So you often have one that you change, you manipulate, and you often have one that you measure some sort. You'll also notice that we try to keep everything else constant. One of the biggest sources of errors in your labs is where what should have been constant between every trial, every group is not. So if you're testing, for example, in this lab, you're going to be testing how long it takes to boil water, depending on the position of the flame relative to your beaker. What's the height difference between your flame and your beaker? You should not ideally also be changing glassware every single time, also be changing water mount every single time, right? You don't want to do that. You want to narrow it down to one thing that you change so you can figure out the relationship with the one result that you get or the types of result that you get, right? Very, very important. You often, as you think about setting up an experiment, have to decide if is it an open or closed system? Is it exposed to the environment or is it contained? All right. Usually flames are actually open because we don't want it to like explode the glass unless we do it in the hood and we have the vacuum on. If you have it closed, that also is very valuable. I used to there are hoods out there where you can't open it. You actually put your hands through gloves and you work with samples through the glass because they're so reactive with the environment that they will either explode, spontaneously combust, or they will degrade. Like they will literally just like break apart at the exposure of air. We flood that hood with nitrogen and no one can get in. There's a whole like vault device that you have to use to even put anything in there. Okay, so that's very high level chemistry. If any of you pursue, which several of you are interested in pursuing higher level chem, you will probably work with one of those tricked out hoods. Then of course you're gathering data. Now there is you know what qualitative and quantitative is, but there is a different type of data when you report in your lab notebooks. There's raw data, which is what you measure. That often goes on the left side. Now, then there's finished data. Using your raw data, you put it into an equation, you calculate the meaningful value, and then you put that on the right side in a finished data table. Okay. There is the difference between trials and experimental groups. An experimental group, this is more terminology, is the different variations of that independent variable. And then you repeat on trials after trials. So let's say I'm testing if having a certain type of hair makes you a smarter student. My first experimental group would be blonde. My second experimental group would be brunette. My third experimental group would be curly hair. And then what I would do is I'd have multiple people I'd investigate, multiple trials. I'm not going to go off of one blonde, one brown, and one curly hair person and be like, yeah, if you're curly haired, you're definitely going to be smarter. Like that's not reliable. So you have multiple trials for each experimental group. Now, oftentimes we are limited in class. So you're lucky if you're going to get 2 trials today. Okay. And then of course the goal is to have accuracy and precision. You want to get the right value, and there usually is a right value with these pre-kit labs. These labs are often kit-based. Now, not this first one. This one's real basic, just to get you actually familiar with fire safety and using the Bunsen burner. Okay. But future labs, there is technically a correct answer. Now, you will never and should never ever, and this was a problem in the first couple of years, people changed the data because they freaked out that they didn't get the right value. That's not how it works. You either get the right value or you talk about all the sources of error. Your data is your data. You cannot change your data. You can talk about, well, I know that this should have been it. So what can I conclude about what went wrong? Right? But never change your data. I had a lot of people that did that and I was just too tired to care. You really shouldn't though. You're basically saying you're not a credible scientist, essentially, right? And then of course we want precision, which is where glassware comes important. The type of glassware you choose is going to affect the quality of your data you collect. If you use a beaker with very few measurement lines dictated for you, you're guessing all the values in between. Is it 225 or is it 223? Okay, but so usually when you talk about measuring liquids, you want to use high lined things like graduated cylinders, berets, stuff like that. It's more precise. Okay, so that's kind of your overview of experimentation. I'm going to upload this video online in a little bit and after class, because period 4 is my prep period for 2023 spring. Don't do this if you're watching this in the future. And the notes are already uploaded on Weebly for those of you that just have to write it down.